Hi, good day. Today we are going to prove the relation between pressure and volume in an adiabatic process, that is P times V to the power K equals constant, where K is the ratio of the two specific heats, specific heat at constant pressure over the specific heat at constant volume. Our aid to prove this relation PV to the power K equals constant is the first law of thermodynamics, that is dq minus dw equals delta U. That is the heat minus the work equals the change in internal energy. And since delta Q, this is an adiabatic process, then delta Q equals 0. And substituting, we neglect the dq is equals 0, minus dw equals du. And dw equals pdv, so minus dw equals minus pdv would be equal to mcv times delta t. But as we know, pv equals mrt. Thus, by cross multiplication, p would be equals mrt over v, which is equal, substituting in pv equals mcv dt, we will get that mrt over v into dv equals mcv times dt. But and substituting here, or sorry, by cross multiplication, transferring cv under in the right hand side to be under r in the left hand side, we get that minus r over cv into dv over v equals dt over t. But since cp equals cv plus r, and dividing all through by cv, we get that cp over cv k equals 1 plus r over cv, that is r over cv equals k minus 1. And substituting in our equation, minus r over cv into dv over v equals dt over t, we get minus k minus 1 into dv over v equals dt over t. That is minus k minus 1, integrating both sides, integrating dv over v would be equals to the right hand side, would be equal to the integral of dt over t. Now, here, after integrating, we get minus k minus 1 into ln v2 over v1 equals ln t2 over t1. But as we know that minus ln a equals ln a to the power minus 1 equals ln 1 over a. Thus, the minus k minus 1 will make the minus sign will make us invert the fraction. Ln v2 over v1 would be equals v1 over v2, and the k minus 1 bracket would be the index of the v1 over v2. So ln v1 over v2 to the power k minus 1 equals ln t2 over t1. But as we know, for any condition of a gas, T equals PV over MR from the relation PV equals MRT. Thus, the left hand side would be remain as it is, and the right hand side would be ln, substituting P2 V2 over MR over P1 V1 over MR, and cancelling the denominator of the numerator with the denominator of the denominator, the MRs together, we would be left with ln P2 V2 over P1 V1. Thus, rewriting our equation, ln V1 over V2 to the power k minus 1 would be equal to ln P2 V2 over P1 V1. And transferring the V2 V1 by cross multiplication to the other side, that will have ln v to the power 1 to the power k minus 1 into v1 over v2 to the power k minus 1 into V2 equals ln P2 over P1. Thus, V1 to the power k minus 1 into V1 would be equal V1 to the power k over V2 to the power k equals ln P2 over P1. And taking the anti-ln of both sides of the relation, will be left with V1 to the power k over V2 to the power k equals P2 over P1. Then P1 V1 to the power k equals P2 V2 to the power k. That's all.